Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to carry out indefinite integration. The technique we're going to be focusing mainly on in this presentation is the power rule. To get us started, let's take a look at some of the formulas that will be guiding our problem solving process. Okay? Alright, as indicated earlier, the main integration technique we're going to be looking at is the power rule. Now, there are two special cases for the power rule that you want to keep in mind when carrying out indefinite integration. The first case has to do with when n is not equal to -1. Okay, so for n not equal to -1, you're going to have the formula, the integral from x to the n dx. So the indefinite integral of this power is going to be x to the power plus 1 divided by power plus 1. And then don't forget that c to be added on there. Okay? And then the next case is for when n is equal to -1. If you have a term and the power is -1, you cannot apply this formula here. There's a special formula for that. For n equals -1, the indefinite integral can be written as x to the -1 dx, and applying the reciprocal property of exponents, this can also be written as the integral of 1 over x dx. In this particular case, the integral is going to be the natural logarithm of the absolute value of x plus c. So you want to pay close attention to the power when you're integrating it to make sure that you do not violate this rule here. Okay? Now, another rule to keep in mind that's easy to overlook or make mistakes on is the constant rule. It's also the power rule, but if you master this formula, you don't have to apply the power rule here. All right. So when you're integrating a constant, let's say a dx, the integral is going to be ax plus c. All right. The reasoning behind this is that you have. Let me just do this on the side to show you why that works. When you're integrating a with respect to x, what you're doing is you're actually integrating ax to the 0th power. Okay, so when you apply the power rule here, you have x to the 0 plus 1 over 0 plus 1, which is ax to the first power over 1, which is just ax. And then you add the c onto it. All right, but you don't want to use all these steps over and over again. If you just master the idea that the integral of a constant is just that constant multiplied by the variable that you're integrating with respect to the first degree. Alright, so that will facilitate your integration process. Some other formulas to keep in mind that can help us rewrite integrands for integration are the properties of exponents. Let's take a look at the ones that are applicable to the examples that we're doing today. Properties of exponents. The first one, we have already applied it here, is the reciprocal property. So if you have x to the -n, for example, this can be written as 1 over x to the n. Or if you have 1 over x to the n and you want to write it as a power, you can just write it as x to the -n. So bottom line, when you reciprocate a term, the power attains an opposite sign. Another property of exponent to keep in mind is the property that applies to radicals. The property for rational exponents. Now let's say you have the mth root of x to the nth power. If you want to write this as an exponent, is going to be as a power is going to have a fractional exponent. The power in the radicand will be the numerator of that fractional exponent, and the index of a radical will be the denominator. Alright, so these are the two tools we're going to be using to rewrite certain terms so we can apply the power rule with ease. Alright, so let's go ahead and take a look at an example. We are to evaluate the indefinite integral. So let's say we have the indefinite integral um, x to the third minus the third root of x to the fifth plus 1 over x squared plus 1 over x minus 5. Okay, we're integrating with respect to x. Alright, let's go ahead and do it. Now, if you notice, we have powers here. If you look at our integrand, this component right here is called the integrand, what you're integrating. Some of them are already powers, some are not powers. Okay, so let's attempt to write everything as powers, and then we'll go from there, okay? So we're going to write it as the integral of x to the third is already a power. Now, how about the third root of x to the fifth? That can be written as a power with rational exponents. So it's x to the power is the numerator, and the index of your radical is your denominator, like that. Plus 1 over x squared can be written as x to the negative 2. And then 1 over x can be written as x to the negative 1. You don't really have to rewrite 1 over x because this is a special case. Okay, and then minus 5 is already a power with the exponent of 0. Okay, so how do we proceed? Now what we're going to do is we're going to carry out term by term integration. You have to remember that the integral and also the derivative operation can be distributed across sums and differences. You do not distribute the integral or derivative across products or quotients. There are special techniques for integrating that, problems of that nature. Okay, so now what we're going to do is term by term integration. We have the integral of x to the third dx minus the integral of x to the 5/3 dx plus the integral of x to the negative 2 dx plus, now x to the negative 1, I can leave it as 1 over x or write it as x to the negative 1. It doesn't really matter. Just remember that this guy right here is the special case. Okay? Minus the integral of 5 dx. So let's make a quick notation just to help you focus on that key point, which is that this right here is the special case. Special case of the power rule, because n is equal to negative 1. When the power is negative 1, you cannot use the standard power rule for that. Okay? Alright, let's go ahead and integrate every other one but this one using the power rule for n not equal to 1. So for this, we'll have x to the 3 plus 1 divided by the power, whatever the power is, plus 1. That's what goes in the denominator. Okay, minus x to the 5/3 plus 1. But to save time, I can write it as plus 3 over 3. 3 over 3 is the same thing as 1. I'm writing it as 3 over 3 because I want to write 1 as a fraction with a denominator of 3, because the denominator of this fraction is 5/3, so we have a lowest common denominator. Okay, so that same power goes in the denominator, 5/3 plus 1, which can be written as 3 over 3, plus x to the negative 2 plus 1 divided by negative 2 plus 1, plus, now what's the rule for integrating this special case? Whenever the power is negative 1, the integral is going to be the natural logarithm of the absolute value of x minus, you remember the constant rule? The integral of 5 is going to be 5x. Okay? Now, is this integral expression complete? Did I anti-differentiate or integrate correctly? The answer is yes, but it is not complete. You have to add that constant. The reason being that there is always a plus 0 lingering in every polynomial expression. And when you integrate 0, you end up with a constant. Okay? Remember, when you differentiate a constant, you get 0. And since the integral is the reversal or the opposite of differentiation, when you integrate 0, you get a constant. That is why we always have a c added onto every indefinite integral. Okay? Alright, so there you go. Now, let's go ahead and make our results look pretty because it looks scary right now. Let's process it. We're going to have x to the fourth power over 4 minus x to the 5/3 plus 3/3 is 8 over 3 divided by 8 over 3 plus x to the negative 1 over negative 1 plus the natural logarithm of the absolute value of x minus 5x plus c. Okay, now let's simplify it a little bit further. This becomes x to the fourth over 4 minus, we can multiply the numerator by the reciprocal of the denominator, which gives us 3/8 of, and then using the property of exponents of the third root of x to the 8th power. So the numerator becomes the power and the denominator becomes the index of your radical. Okay? Plus divided by minus is minus, and we can reciprocate x to the negative 1, so 1 over x, plus the natural logarithm of the absolute value of x minus 5x plus c. Okay, so ladies and gentlemen, that is the final answer. That's the indefinite integral of the original problem that was provided. Alright, so how well did you master the contents of this presentation? To demonstrate mastery, we'd like you to try out the following problems. So try these. Instructions are to evaluate the following. Indefinite integrals. Okay, evaluate the following indefinite integrals. So question 1, what if you were to find the indefinite integral of 1 over x to the third power minus 1 over x squared plus 1 over x. You're integrating this with respect to x. Question number 2, what if you were to find the indefinite integral of 3 minus the cube root of x to the 5th minus 1 over 2x squared. And then number 3, what if you're to find the velocity function, find v of t, where the acceleration function a of t is equal to 2t to the third minus 5t squared plus 1. Okay, so go ahead and attempt these 3 problems, pause the video presentation and do it. When you're done, reinitiate the playback so that you can see what the correct answers to these 3 questions are. Alright, hopefully you had a chance to try out the problems. The answers to try these problems are as follows. The first one, the answer is negative 2 over x squared plus 1 over x plus the natural logarithm of the absolute value of x plus c. For number 2, the answer is 3x minus 3 over 8 times the third root of x to the 8th power plus 1 over 2x, and you do not want to forget your c value. And then for the last one, you just have to remember CEVA, okay? You have to remember that if you're going down, you differentiate, and if you're going up, you integrate. So if you're going from acceleration to velocity, what you do is you're going to integrate and add your constants, all right? So what this question is basically asking you is what is the indefinite integral of this acceleration function, Okay, so if you integrate your acceleration function, which is basically what the velocity function is, your answer is going to be t to the fourth over 2 minus 5t to the third over 3 plus t plus your constant c. Okay? Thanks so much for taking the time to watch this presentation. We would like to know what you think. If you found the contents of this tutorial helpful in your studies of indefinite integration, do give us a thumbs up. If you have any questions, comments, or requests, just post it in the comment section below. Don't forget to subscribe to our channel for updates to other tutorials such as this. More resources can be found at math.serve.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.